the first question is, explain the meaning of differentiation and what are the techniques of differentiation. The answer is, differentiations mean finding the rate at which something changes. In simple words, it tells us how fast one quality change compared to other. Usually, it tells how Y change when X change. For the technique of differentiation, there are a few rules or technique to make differentiation easier. And we have 4 techniques. First, we have power rule, which is d over dx in bracket and x to the power n minus 1. For the second technique, we have product rule. If y equals to uv, then y prime equals to u prime v plus uv prime. And for the third technique is quotient rule, which is if y equals to u over v prime, then y equals to u prime v minus uv prime over u square. And for the last technique is chain rule. If y equals to f gx, then y prime equals to f prime gx times g prime x.
Now we move to the question 2. Find dy over dx for the following functions. F y equal to x power of 3 e power tan round brackets 3x. First, notice that this function is a product of two functions, x power of 3 and e tan round brackets 2x. Since the functions involve multiplications, we apply the product rule. The product rule states that the derivative of uv is u times the derivative of v plus v times the derivative of u. Now, let u equals to x power of 3, v equals to e times round bracket 2x. Next, and to differentiate e times round bracket 2x, we use the chain rule. The derivative of exponential functions is the same function multiplied by the derivative of the exponent. So, the derivative of e times round bracket 2x is e times e power of tan round bracket 2x times the derivative of tan 2x. The derivative of tan 2x is 2 sec 2 round brackets of 2x. And next, we apply the product rule. We multiply x power of 3 by the derivative of e power of tan round bracket 2x, and then add e tan 2x multiplied by derivative of x power of 3. And this may give dy over dx equals to d power of 3 round brackets 2e power of tan round brackets 2x sec 2 round bracket 2x plus e tan e power tan 2x round bracket 3x power of 3. So, the final answer for this question is dy over dx equals to e power of tan round brackets 2x x power of 2 round brackets 2x sec 2 round brackets 2x plus 3 plus 3. Let's move on to the part B. We are given the function y equals to natural log round bracket sin x over square root x power of 3 plus 5. This is a question, so we apply the quotient rule. The quotient rule states that the derivative of u over v is v times the derivative of u minus u times the derivative of v, all divided by v squared. Then we let the u equals to natural log round bracket sin x and v equals to square root 3 power of x power of 3 plus 5. We differentiate u. The derivative of natural log round bracket sin x requires the chain rule. The derivative is cos x over sin x. Next, we differentiate v. We rewrite the square root as a power round open brackets x power of 3 plus 5 closes bracket powers of 1 over 2 using the chain rule. The derivative becomes 3x squared over 2 square root of x power of 3 plus 5.
Both sides with respect to x using implicit differentiation. First, we differentiate the left-hand side. From the term e to the power of xy, we apply the chain rule. The derivative is e to the power of xy times y plus x dy dx. Next, we differentiate the natural log of x plus y.
To approximate the f1.02, choose a suitable point A, which is the suitable point A close to 1.02 is a 1. And then for the next step, we can find the derivative f prime x equals to the quotient minus 2. Our quotient rule is cube root f1 prime x equals to u prime 0 minus u minus 2 over v squared, where u equals to ln x, and then we can evaluate the fa, which is the f1 x to the power 1 over 3. So our u prime equals to 1 over x minus 2. Our v prime is 1 over 3x to the power negative. We can evaluate the fa, which is the f1 equals to ln x equals to 1 over x cube root of x to the power. We can get 1 over 3 minus ln minus 2 minus over 1 times with negative 2. 1 over 3x. We can evaluate the fa, which is the f1 equals to ln 1 minus 2 over 3 cube root of our f. We can get x equals 0 x negative 2 over 3 equals to 1 over 3 ln f2. And then we can evaluate the fa, which is the f1 equals to ln 1 minus 2 over, and we can get cube root of 1 over x minus 0 x minus 2 over 3x over 1 to the power 4. For the next step, so we can evaluate the formula, which is the Lx equals to f prime plus f1 equals to 1 over 1 bracket minus ln 1 minus f minus 2 over L 1.02 equals to the power 4 plus f prime 1 1.02
and we can
minus
get
1. The answer
So
1 minus
L
1.02 equals to
minus
2
over
plus
3
5
equals
over
to
3 1 plus 2 over 3 we can get 5 over 3. And then
so
we can evaluate the f
prime
prime plus
A by
negative
f
2 plus
prime
0.1 over
1
3
equals to 1
and
over
L
1
minus ln
1
1 minus 2
2
over 3 1
equals to
negative
the
2
power
plus
4 over 3
0.3333
and we can get
L the answer 1 minus 0.02 equals to
minus
negative
2 over 3
1.99
equals to
1 plus
9666
and then
2 over 3
we can round
get
to
5 over
3
3
decimal places.
so
L
we can
1.02
evaluate the f prime A
equals to negative
by f
1.967
prime
1 equals